Alright, today's lesson is over curve-fitting quadratic models. Now, this is going to require the use of solving systems of equations by both elimination and substitution. If you did not watch the previous video, which reviews those items over solving systems, then you need to make sure you watch that video first. Otherwise, this would be very, very confusing. So, before we write the equation of a quadratic given some points, let's talk about whether or not to determine if a set of points is quadratic at all. So what we can do is we can talk about the common difference. Now, common difference means that when I subtract 9 minus 4, I get negative 5. 4 minus 1, negative 3. 0 minus 1, negative 1. 1 minus 0 is 1, 4 minus 1 is 3, 9 minus 4 is 5. So you take the right number and subtract the number immediately to its left to find the first common difference. Now we'll notice that none of the numbers repeat in the first common difference. This means that it's not a linear function. So what we can do is we can check the second common difference. Negative 3 minus a negative 5 is positive 2. Negative 1 minus a negative 3 is a positive 2, and so on and so on. So what I see here is that the second common difference is the same across the board, 2, 2, 2, and 2. That means that this is going to be a quadratic equation. Alright, so let's do some examples. To determine if this is a quadratic function, we need to subtract the y values. 1 minus a negative 1 is a 2. 7 minus 1 is 6. 17 minus 7 is 10. 31 minus 17 is 14. So looking at the first common difference, there is no common first difference. So what I need to do is continue on and find the second common difference. 6 minus 2 is 4. 10 minus 6 is 4. And 14 minus 10 is 4. So the second common difference is constant, and it's 4, 4, 4, 4. So this would be yes, it is a quadratic. Oops. It is a quadratic because the second difference is the same. Now, I do want to caution you in future problems. I want you to make sure before you just dig into the y's to verify that the x values are equally spaced. So I have every other whole number. So 1, 3, 5, 7, 9. These are all evenly spaced by 2, which means my y values are all evenly spaced, so I can check for the common difference. So in this problem right here, are the x values evenly spaced? Yes, 3 to 4, 4 to 5, 5 to 6, 6 to 7 is all up 1. So these y values and x values are okay to check for the common differences. 3 minus 1 is 2, 9 minus 3 is 6, 27 minus 9 is 18, and 81 minus 27 is 54. So there is no common first difference, which means this is not a linear function, so I would subtract the second common difference. I get 4, 12, and 36. Alright, what this means is that these numbers are not constant, so this is not a quadratic. So it's not quadratic because the second common difference is not a constant. Alright, so let's check this one. 10, 9, 8, 7, 6. My x values are equally spaced. Finding the common differences. Okay, and when I get the first common difference, I notice that immediately the first common difference is the same across the board. This means it's not a quadratic, but it's actually a linear function. Alright, so for the next problem, it is a use-try problem. I'd like you to pause the video and give it a shot. When I flip this slide, you'll see the answers, and we'll talk about whether or not you got it right. Alright, so we have a second common difference of 4, 4, and 4. Because the second common difference is constant, this is a quadratic. So remember that collinear means that 2 points lie on the same line. Non-collinear means that they don't lie on the same line. Now, collinear, any 2 points will be able to be connected by a line. So non-collinear actually means that you have to have more than 2 points. So let's say, for example, if I added a third point here, these 3 points are non-collinear. Now, we can actually take 3 non-collinear points to define a quadratic equation. They are going to help us find the a, the b, and the c in the standard form of a quadratic. Okay, so we are actually going to use a systems of equations to solve it. Now, what's really cool here is that you do not need equally spaced x values. So that's cool.